As our first example, we're going to evaluate the integral of square root 25 minus x squared by trigonometric substitution. The substitution we're going to make is x equal to 5 sine theta. So this is not an obvious substitution in the least. However, after you see an example, you'll start to see why and where this is going. The first thing that you would probably want to know is, what about the differential? Well, the differential is going to be dx equals 5 derivative sine is cosine theta d theta. Now notice, we don't need to be worried about the fact that there's no cosine theta in our problem. There's no sine theta for that matter in our problem. What we're doing here is we're substituting the x value. So we're going to replace this x by a 5 sine theta. The dx is going to be replaced by 5 cosine theta d theta. Now here's the real kicker, the reason why we actually go about this. Look at the radical, 25 minus x squared. Based on our substitution, that is going to become 25 minus x squared equal to 25 minus, and remember x is 5 sine theta, so that's going to be x squared 25 sine squared theta. Now, what's the big deal about this? Well, the radical then can be written as 25 minus 25 sine squared theta, or, after factoring out the 25, 1 minus sine squared theta. And that's pretty good because 1 minus sine squared, of course, is cosine squared. So the expression under the radical gets simplified to 25 cosine squared theta with this substitution, and this is exactly why we use the substitution of x equals 5 sine theta. So now we're going to end up just taking the square root of, instead of two terms, the square root of just one term, and that one term, moreover, is a perfect square. So let's do that and see what we get. Okay, so we have the integral of square root 25 cosine squared theta, and instead of dx, remember we had that as equal to 5 cosine theta d theta. And now we can work with the trigonometry. So let's take the square root of this expression. That's going to give us 5 multiplied by 5 is 25 integral. And the square root of cosine squared is just cosine, but we have this extra cosine, so we're back to having cosine squared theta d theta. And the way to evaluate cosine squared theta is by one of these handy identities. Cosine squared theta is equal to 1/2, which I'm going to put on the outside, is 25 over 2. Cosine squared theta is 1/2 1 plus the cosine of 2 theta d theta. So basically, in the last section where we dealt a lot with integrals involving powers of sine and cosine, that comes into play with some of these. Now, 1 plus cosine 2 theta is very easy to integrate. We get 25 over 2. The 1 is going to turn into just theta. And when we integrate cosine 2 theta, we're going to get minus 1/2 sine 2 theta. And then, of course, plus c. So the integration is done. Now, the only thing that we have to do is turn this back into x's, and then we have our answer. So to do that, we're going to need a drawing. Go back to our original substitution, which is x equals 5 sine theta, and draw a triangle. I'm going to make theta my angle, and if we divide by 5, we'll see that the sine of theta is x divided by 5. So the sine of theta is equal to x, so that's the opposite divided by hypotenuse 5, and there's our triangle. Now from the Pythagorean theorem, it's easy to find the missing leg. It's the square root of 25 minus x squared. And of course, if you square this, you get 25 minus x squared. Square this, you get another x squared. Adding the two, the x squareds will cancel, giving you with 25, which is exactly the square of the hypotenuse. Now, this allows us to find things like, the cosine of theta, which would be root 25 minus x squared over 5, the tangent of theta, and even a sine of 2 theta. What we're going to have to do here is a little bit of work. First thing, to get theta itself, well, that part's pretty straightforward. The sine of theta, as we know, is equal to x over 5, which means that if you want just theta itself, it's equal to the inverse sine of x over 5. So that's going to come right here. But in order to plug in the sine of 2 theta, that's not as easy to get because we only have a theta with our triangle. So that's the part that needs work. But it doesn't need too much work. It's a simple trigonomic identity. So what I'm going to do here is come up and over, and I'm going to write this as 25 over 2. And I'll keep it theta for now. And the identity I was referring to is that sine 2 theta is equal to 2 sine theta cos theta. And the 2's cancel. And we can't forget about our friend the plus c. And now we're in business. We have the theta, which is inverse sine x over 5. The sine of theta and times the cosine of theta, we can get each of those from the drawing, and we are done. So let's write out our answer. So we have 25 over 2 times theta, which is the inverse sine of x over 5, minus the sine of theta times the cosine of theta. Sine of theta we know is x over 5, multiplied by the cosine of theta, which is root divided by 5. And so we'll include that in our fraction. Over 5. So that's going to be times 5 in the bottom, or we can just make that into 25 here. And that's what sine theta cosine theta is. So that's how to deal with the sine 2 theta portion of things. And at last, we put our plus c. So our final answer is 25 over 2 inverse sine x over 5 minus x squared root 25 minus x squared over 25 plus c.